Okay, let us continue. We'll do some applications of conservation of linear momentum, which is very important. Now, suppose a question is there in which a bomb is there, which explodes into two parts. So it explodes into two parts, which is in the ratio of 1:2. The total mass is m. This is the ratio of 1:2. If the heavier mass moves with velocity v after explosion, so what is the velocity of first mass? That is the question. So you can try this, pausing this. Okay. Now we know that because there is no external force, we can say that sum of all forces equals to 0. That means the momentum of the body is conserved. Initial momentum equal to final momentum. So initial momentum of the body, because it was at rest, it will be 0. Final momentum will be small m, mass of the first part into velocity v. This will be minus v because it is going in negative x direction, plus mass of the capital part m2 into capital. So we'll get small v equals to m2 capital V by m1. So this will be 2 in the ratio 2:1. So answer will be equal to 2v. Right. So this first type of question. Another type is, suppose you are projecting a bomb with velocity v at an angle of theta. So the bomb will be going like this, right? And at the highest point of this trajectory, the bomb explodes in two parts, which is also in the ratio of 1:2. So the heavier part falls downwards and the lighter part goes ahead. So it falls somewhere here, right? So Achana, it is, yeah. So what is the velocity of the lighter path? That is the question. This is in the ratio of 2:1. So if we see at highest point, we can try, pause and try. So if we see at the highest point, the ball which is there, it breaks into two parts. Okay. Now at the highest point, there's only one force acting, which is mg in the downward direction. So that means in the vertical direction, we cannot conserve momentum because there is a external force. But in the horizontal direction, we can certainly conserve momentum because there is no external force in the horizontal direction at the highest point. So sum of fx equals to 0. Now because this is 0, we can quite easily solve this. So this velocity is v. So you solve the question. Initial momentum equal to final momentum in x direction. So in x direction, initially the velocity of this mass here will be v cos theta. Only cos component remains, sine component is 0. This will be m into v cos theta equals to final mass will be in the ratio of 1:2. So this will be m by 3 into v. Plus due to heavier mass, it will be 0 because in x direction there is no velocity. So solving this, you can get the answer. This will be v dash. So v dash will be equals to 3v cos theta, which is your answer, right? Now there can be another question in which they might say that this heavier mass, instead of falling down, it retraces. So similar concepts can be applied and solved. Okay. Then another interesting question which we deal in center of mass is, you can pause and write the questions. Okay. Now here is a person of mass m. Here is a person of mass m. Hopefully I'm recording all this. Yeah. Person of mass m is there and plank of mass capital M is there and the length of the plank is L. So you have to find out the displacement of the plank with respect to water. Displacement of plank. So basically you have to find out the displacement of plank. Okay. So in this question we know that the displacement of the man with respect to plank, this is equals to L because the man will move towards positive direction in L like this. So that means displacement of man will be equal to L plus displacement of plank. Right. This is one equation which we have. Now another important thing to consider is that because there is no external force on the system, the F external equals to 0. Because this force is 0, that is why we can say that the center of mass won't move because initially it was at rest. So then final velocity should also be at rest because there is no acceleration. So velocity is same, 0. Okay, so center of mass will not move. So let the center of mass be 0. We can take for calculation's sake. Now if this is 0, then we can write 0 equals to XUM formula will be mass of man into displacement of man plus mass of plank into displacement of plank by total mass. Solving this, you can get the answer. You'll get 0 equals to m into displacement of man can be written as L plus displacement of plank plus m into displacement of plank. So solving this, you get the answer. Displacement of plank equals to minus ml by capital M, which is your answer. So this step is the crux of the question, that whatever data is given, you express properly and you'll get the answer. Okay. Now there can be another question in which similar on the similar lines. Suppose there is a big mass on which a small mass m is kept. This mass is capital M, and this is kept on a frictionless surface. It's kept on a ground but it is frictionless, like that. So now this small m is released. So this small m is released and it reaches the opposite end here. So we have to find out the displacement of capital M. How much is the bigger block moving? Now again, if we solve this, you can pause and try. Now again, if we solve this, we have been given that displacement of small m with respect to capital M. This will be equal to, so the initially the mass was here, then finally it is here. So it was moved by displacement 2r. So the radius is r, right? This is equals to 2r. So you can write displacement of small equals to 2r plus displacement of capital. And we know that the center of mass will be here. Suppose where the center of mass is there. So the center of mass is, suppose it is taken as 0. And because there is no external force on the body, we can say that the center of mass will remain at 0 because the acceleration is 0. So velocity is also 0. And x will be 0 then. So applying the formula, we'll get the answer. M into xm plus capital M into x capital M by small m plus capital M. Solving this, you'll get some answer, which is the displacement of the plank. Right. Like that. Then another question, which is on the similar lines. I don't think we need to do this. Why did we? Maybe you can do it as a homework. Suppose there is a plank here, and on one end of the plank there is a man, whose mass is m. Another end of the plank, there is another man whose mass is m. And the length of the plank is given as L. And the mass of the plank is given as 3m. Okay. Now, if it is given that both men exchange their position, so you have to find out displacement of the plank. That is the question. There is a homework for you. You can try it out. All right. So I'll stop the recording here.